Section 3.2 is about significant figures. So significant figures, the definition down here is it's all digits of a measured quantity that you know with certainty. So this is Baker Mayfield. You guys probably know a lot more about him than I do, but he holds the record for the longest pass at 70.5 yards. So his longest pass is 70.5 yards, or do we know it for 70.5.000000105? We do not know all these digits, right? Because we were on a football field, and you only know how long the pass is to a certain number of digits because of the scale of the field and how well you can measure. Okay, so significant figures tell you how well you were able to do your measurement, like how many digits or how precisely you know your number. All right, so let's look at this example. So this is, we did this before. This is our Tootsie Roll, right? And here we have our scale. So we know the scale to every centimeter here, all right? And we have one mark in between, but we don't have 10 marks in between, so we don't know it to another digit, okay? So if we measure our Tootsie Roll here, let's see, it ends right about, I would say, I'm going to guess. Remember, we get to guess one more, 2.6. Our uncertainty here, so half of the smallest mark is 1, so it's going to be plus or minus 0.5 centimeters. And these are centimeters, right? So how many digits do we know? Well, you can see our measurement right here is 2.6, all right? So we know our measurement to 2 digits. So this number right here has 2 significant figures, all right? So significant figures only count for measurements, all right? We only have to think about significant figures with measurements if we actually count something. Say that you're counting, the number of basketballs here I have, or you're counting the number of cars that pass an intersection in 20 seconds or whatever. You do not need to apply significant figures to that because you're actually counting objects, and that's just a number, right? We only have to worry about significant digits when we use our scales. So it's important for things like mass, temperature, volume, things like that. So there are 3 rules for identifying how many significant figures, because a lot of times you will just be given a number and you won't actually have access to the scale, so you need to know how many digits you need to keep, right? Because I know you guys have all plugged in numbers into your calculator before, and you just get a long stream of numbers, all right? So that's the actual calculation. We don't know if those numbers are correct or not, so we're going to have to round. So there's 3 rules for identifying significant figures, okay? So the first of these is that all non-zero numbers are significant, okay? That's the first rule. All non-zero numbers are significant. So let's look at this number right here. So for number 1, we have 1,238.24. So how many non-zero numbers are there? There's 1, 2, 3, 4, 5, 6. So this has 6 significant figures. All right. The second rule is that all zeros in between non-zeros are significant. So all zeros between non-zero numbers are significant. All right, so that kind of makes sense here. So here we have 4,004. So that means that the 2 zeros in between need to be counted. So there's 1, 2, 3, 4. So this one has 4 significant figures. All right, and the last one is that zeros that are after a decimal point, so zeros after the decimal point, and there's another point here, and they have to be after a non-zero number. Are significant. Okay, so they have to be after the decimal and after a non-zero. So that means that these two zeros right here at the end of this number, 21.8500, these two zeros are significant. So this one has 1, 2, 3, 4, 5, 6. This one has 6 significant figures. All right, so those are the 3 rules. So those are the only 3 rules you need to remember to identify significant figures. So let's go ahead. Oh, here we go. I did type these. All right, so let's go ahead and practice. All right, so let's look at and identify the number of significant digits. So you guys can go ahead, if you guys want to practice, you can go ahead and pause me right now and go ahead and do this on your paper and then unpause me and you can check. All right, so the first one, 253, everything is non-zero, so that's going to have 3 significant figures. The second one is the same, 45.2, 3 non-zero numbers. All right. Now this one, 400. All right, we have 1 non-significant figure. Our zeros right here, they're not trailing. They're not in between 2 non-zeros, first of all, and then there is no decimal point, so they are not significant. So this means that we only have 1 significant figure. Now here we have a 0 that's in between, so it will be significant. So 1, 2, 3, 4, 5. This has 5. All right, this one, we have zeros to the left, but we don't have any zeros. Remember, if they're after a decimal point, they also have to be after a non-zero number. So there's only 2. These are the only 2 significant figures. The zeros on the left are not significant. 601, so there's 2 non-zeros. There's 1 0 in between, so that will be 3. All right, 0.102. So we said zeros on the left are not significant, but the 0 in between is, so this will also have 3, the 1, the 0, and the 2. 35,000 right here. So there is no decimal point, so these zeros are not significant, so that means that we have 2 significant figures. 9.81, those are all non-zeros, so that will be 3. And 0.0005. So there's no trailing zeros here. If there were, they would be significant, but it's just this 1 5 here. So this just actually has 1. Okay. All right. So now we can identify the number of significant digits that we have. So now we have to think about what to do with calculations. So we're going to be doing lots of calculations, especially for the results in our lab. So there are 2 rules there's 1 rule for addition and subtraction, okay? There's another one for multiplication and division. So the first rule for addition and subtraction with significant figures is that you use the smallest number of decimal places for the final number of decimal places in your number. So you actually don't have to count the significant digits. It's all about the decimal places, okay? So that's what we're going to consider for addition and subtraction. So let's go ahead and look at that. Okay, so here's our example. So our example is for addition, if we take 21.3 plus 5.51, all right? If we just do this calculation, all right, we are going to get, let's see, let's go do this in my head. We're going to get 26.81 centimeters, okay? Now we have 1 decimal point here, and we have 2 decimal points here. So we need to use the smallest, so we have to use the 1. We only know it to 1. So we just want to keep this decimal point right here. So it actually, the final answer with significant figures should be 26 point, and we have to round here. Since the digit right here is a 1, we can just round down. If you guys remember rounding, if it's 5 and above, you bump the number to the left of it up. If it's 4 and below, you just leave it as it is. So we're going to have 26.8 centimeters rounding. All right, so here's some more examples, all right? So once again, you can guys, if you want to, you can work these on your own and then pause me, work them, and then start again to check them. All right, so if we take 2.4 meters minus 1 meter, that gives us 1.4 meter. All right, now considering significant digits, we have 1 decimal point here. We have 0 decimal points here, so we need to drop this. So our final answer is actually just going to be 1 meter. All right, the next problem, 90.4 millimeters plus 4.5 millimeters. If we just put this into our calculator, what we will get is 94.95 millimeters. And notice that I'm writing all the units. You guys will need to do that too. Now we have 1 decimal point here. We have 2 here. We have to take the smallest, which is this 1. So we need to keep just this 1 decimal point. Okay, so we're going to have to round. Now we do have a 5 here. So the 5 is going to bump the 9 up. Well, since it's a 9, that's going to actually, since it's at the end, we're going to have to bump up the next one too. So our final answer would actually be 95.0 millimeters. Since this 5 bumps that 9 up to a 0, then we have to carry the 1 over to the next spot. Okay? Lastly, we have 100 milliliters plus 3.6 milliliters. So if we put this in our calculator, we get 103.6 milliliters. All right, taking into account significant digits, we have 0 decimal points there. We've got 1 there. All right, so we have to round to this spot right here. This 6 is going to bump the 3 up to 1. So we know we have 104 milliliters. Okay. Now we're going to move on to multiplication and division. So multiplication and division has a different rule. All right, so if you're multiplying and dividing significant numbers, you actually do need to count the number of significant digits, and it's the smallest number of significant digits that determines the final number of significant digits in your answer. So let's look at our example here. We have 123 meters times 6.4 meters. If we plug this into our calculator, we get 787.2 meters, okay? Now this one has 1, 2, 3 significant digits. This one has 2. So we have to just round this to 2 significant digits. So that's just keeping these 2 numbers there. So our final answer would be, we're rounding to here, so this 7 is going to bump the 8 up 1. So 790 meters would be the final answer. All right, here's some more examples. Once again, feel free to work these, on your own and then come back. So the first one, we take 200 times 35.4. That would give us, if we plug it in our calculator, 7,080 meters. All right, now we have 1 significant digit here. We have 1, 2, 3 significant digits there. So taking the smallest, we only can keep 1 significant digit. So that means that's 7. This is the only one we can keep. So if we round that, the 0 is going to just stay the same. So it's 7,000 meters is our final answer. All right, let's go ahead and do the second one. So if we take 35 and divide it by 7, we end up getting 5, right? Now, this one is interesting because this one has 2 significant digits. This one, this 0 is significant because it's after a decimal point and it's after a non-zero. So we have 2 here. So our final, this is milliliters, our final answer, we want to have 2 significant digits. Well, we just have 1 here because we know that 35 divided by 7 is 5. But we can add 1, so it could be 5.0. That's now we have 2 significant digits, just like we did in our 7.0 there. That one's a little bit different, a little tricky. And we will practice this much more in class.